In this video, we're going to be working through the 6.6 quiz review. So turn to Thursday's page in your packet and follow along. Try question 1 on your own, and then we'll do it together. Okay, for question 1, we have x is less than 2. This represents a vertical line that goes through x is 2. So since it's a less than symbol, we're going to have a dashed line, and less than 2 means we're going to shade to the left. So this area over here, I'm just doing some quick shading, something easy to erase. For our next line, we'll make this the blue line. We don't have this written in slope-intercept form, so we need to get y by itself on the left. I'll add x to both sides, which leaves us with y is less than or equal to x plus 2. Let's imagine there's a 1 here, which makes it really easy for us to identify our m and our b. Our y-intercept is positive 2, and our slope is 1 over 1. So we'll go up 1 and right 1. We'll also continue the pattern in the other direction. And this one's going to be a solid line because our inequality has an equal to component. Now for shading, since it's a less than, we're going to shade below the blue line. Looking at our graph, we can erase any of the shading that only contains one color. We're looking for the region that is a solution to both. Oh no. Let me redraw that. We're looking for solutions to both of the inequalities, so if it's only a solution to one color, then we can erase it. So it's this area right down here that represents our shaded region. Now try number 2 on your own as well. Welcome back. We need to get our first inequality in slope-intercept form, which means y by itself on the left, so we can subtract x from both sides. I'm going to throw a 1 here in front of the x so we can see that our slope is negative 1 and our y-intercept is negative 1. That's going to go through this point here, and then our slope will take us down 1 and right 1. I'm going to continue the pattern in the other direction as well. Let's draw our line, which in this case will be a solid line. And shade below because it's a less than symbol. Do some light shading. For the second line, we need to get this in slope-intercept form as well, so we'll subtract x from both sides, leaving us with y is greater than or equal to negative x plus 3. Throw a 1 in front of that x to make it easy to see your slope and your y-intercept. That means we'll cross the y-axis at positive 3, and our slope, again, is negative 1. So we'll go down 1 and right 1, continue the pattern in the other direction as well, and our line this time is also solid. This inequality is greater than, so we're going to shade above the line. Remember, the solution to a system is the region that contains shading for both lines, but the shading on these two lines doesn't actually cross each other, so these are not solutions, and these are not solutions. This is a strange example. We haven't seen one quite like this before. There are no solutions to this system. There's no shaded region that satisfies both of the inequalities. Now try number 3 on your own. For number 3, we need to start by adding x to both sides. That way we can get y by itself on the left. And I'll throw a 1 here so we can see our m is 1 and our b is 4. So we'll start by plotting b, our y-intercept, And then we'll use our slope to go up 1 and right 1 and continue the pattern in the other direction as well. This line is going to be dotted or dashed because we don't have an equal to component in our inequality. We are going to shade above it since y is greater than, and then we can move on to our next line. We'll need to subtract x from both sides to get y by itself, and that gives us an m of -1 and a b of +2. So -1 is going to go down 1 and to the right, and this line will also be dashed. We will shade above since y is greater than. So it looks like the area where these two shaded regions intersect is right here. So just a small area up at the top, and we can erase everything else. Numbers 4, 5, and 6 have similar instructions. We just want to graph the inequalities, the system of inequalities. So go ahead and attempt number 4 on your own. Alright, in number 4, we don't have to really do much work because these are already both written in y equals mx plus b form. So let's start with our first line. Our m is 1 and our b is 1. So our y-intercept, our slope, take us in this direction. It's kind of hard to see the lines on this graph, but I'm kind of estimating here. This is going to be a dashed line because our inequality does not have an equal to component. And we will shade above the dashed line because its y is greater than. For the second line, we'll look at this as a -1x. So our m is -1 and our b is +1. So +1 is our y-intercept, and our slope goes down 1 and right 1. Trying to estimate where the points would be here. This is going to be a solid line because our inequality has an equal to component, and we will shade above this line. Now we're looking for regions that contain shading of both blue and green, which is going to be this region right up top. Everything else can be erased, all the other shading, and you have your solution. Try number 5 on your own. Okay, for number 5 as well, we can just jump right into graphing because these are already in slope-intercept form. Our first equation has an m of -1 and a b of +2. So we'll go down 1 and right 1, and then draw a solid line and shade above. For the blue line, we have an m of 2 and a b of -2. So our slope is going to take us up 2 and right 1, and then down in the other direction as well, continuing the pattern. This line is going to be dashed, and we will shade below because its y is less than. So we're looking for a region of shading that contains both blue and green. Looks like this area right over here on the right. All of the other shading can be erased. And that's your solution. Now work on number 6. For number 6, we already have our inequalities in slope-intercept form, so identify your m, your b. Our y-intercept is +4, and our slope goes up 2 and right 1, but that goes off the graph, so I'm going to go down in the other direction. And this will be a dotted line for which we'll shade below. So all of this area over here. For our next line, our M is 1 and our B is also 1. So we have a y-intercept of 1 and a slope of positive 1. That'll go up 1 and right 1, then go in the other direction as well. This line will be solid. And for this line, we want to shade above. So that's all of this area above the blue line. The only region in which these two shadings overlap is in this skinny part right here between the two lines. So I'm doing my best to shade it so that you'll still be able to see it. Everything else, all the other shading, can be erased. The instructions for 7, 8, and 9 are a bit different. For these problems, we want to write a system of inequalities. So we're given a graph and we want to write the system. The way we do that is by looking at the boundary lines. So I'm going to make this boundary line my green line, and I'll make this boundary line my blue line. That'll just help me talk about these problems a little bit more easily. So why don't you try number 7 on your own? Okay, the easiest way to do problems like these are to identify your M and your B. My green line has a boundary, or a slope, of, looks like positive 1 over 1, which is the same thing as 1. My y-intercept is positive 2. So if I wanted to write this in slope-intercept form, my y would be y equals 1x plus 2. But in an inequality, we don't write equals. The shading is below this line. So we're going to be using a less than symbol. But since it's a solid line, it'll be a less than or equal to. So I'll write this down. Solid and below will give us a, well, let's do it this way. Below and solid gives us a less than or equal to. Now let's focus on the blue line. The blue line, if I pick 2 points and look at their slope, I have a rise over run of 1 over 1, which again is positive 1. The y-intercept is negative 3. So if I write this in slope-intercept form, we get y and then 1x minus 3. But let's figure out what kind of inequality symbol. For the blue line, we've shaded above and the line is solid. So that's going to give us a greater than or equal to symbol. So let's just write this nice and neat. Our solution to this problem needs to be a system of equations. Sometimes you'll see a symbol like this out in front of a system. We'll just write our two equations down. Y is less than or equal to x plus 2, or you could say 1x plus 2, that's fine. Y is greater than or equal to x minus 3, or 1x minus 3. And this is our solution. Now try number 8 on your own. For number 8, I'm going to color my 2 dashed boundary lines in. I don't know if you can tell, but I really love color coding. So much easier to talk about the blue line and the green line. Okay, so for our green line, we have an M and a B. Our M is, let's see, negative 1 over 1, so a rise of negative 1 over 1, which just gives us negative 1. And then the y-intercept goes through the point 0. So this would be y is equal to negative 1x plus 0. But instead of an equal to symbol, we've got a dotted line, shaded, well, let's do it the other way around. This shading is above the green line, so that's going to be above and dotted. So that'll be a greater than symbol, and there's no equal to component here because it's dotted. So I'll just leave that blank. So here's our symbol. For the blue line now, we have a slope. It looks like we go up 1 and right 1. So that's a slope of 1 over 1. Simplifies to 1, and a b also of 0. So if we were to write this in slope-intercept form, we would get y equals 1x plus 0. And for the blue line, we've also shaded above, and it is a dotted line. So this gives us a greater than and a no equal to component. So here's our symbol for this. Now let's rewrite this in the way we would typically present our solution. Our first inequality is y is greater than negative x. We don't have to write the 1, and then we also don't have to write the plus 0. And our second inequality is y is greater than x. Question number 9. Attempt this one on your own. For number 9, we are going to start with the green line. Here, if we pick any 2 points, let's say these 2 points, and try to find our slope, our rise is 0. So our rise over run is 0. Our b, on the other hand, is positive 1. So putting that in slope-intercept form, we get y equals 0x plus 1. Instead of equals, though, we need to figure out what type of an equality symbol to use. So we have shaded this below the line, and the line itself is dotted. So the below gives us a less than, and the dotted does not give us an equal to component, so this is the symbol we use. Now for blue, we have, if I pick any 2 points, how about these 2 right here? It looks like my rise over run is 1 over 1, which is just positive 1. My y-intercept is 0. No, I'm sorry, I didn't look at that right. That goes through the point positive 1. So our slope-intercept form is y equals 1x plus 1. And this line is shaded above, and it's solid. So the above is going to give us a greater than symbol, and the solid is going to give us an equal to component. So here is our symbol for this one. Let's rewrite our answer. Y is less than 1. Notice I didn't write the 0x. You don't have to write that. And y is greater than or equal to x plus 1, or you could write 1x plus 1. We have 2 problems left. They're both word problems, so attempt number 10 on your own. Alright, let's do number 10 together. Diego started an exercise program in which each week he works out at the gym for 4.5 to 6 hours, and he walks from 9 to 12 miles. So we're going to make a graph that shows the number of hours Diego works out at the gym compared to the number of miles he walks per week. So we can think of his hours as, or his gym hours as X and his walking miles as Y. That will help us while we're writing our inequalities. So we need to start by actually writing inequalities to represent the information we're given. He works out at the gym from 4.5 to 6 hours. So since gym is represented by X, X has to be in between 4.5 and 6. So we would write that like this. 4.5 has to be less than or equal to X, which has to be less than or equal to 6. This is how we represent that X is in between those two values. The other piece of information we're given is that he walks between 9 and 12 miles. So this is very similar. If Y is in between 9 and 12, we would write that expression like this. 9 is less than or equal to Y is less than or equal to 12. So now let's draw these both on the graph. For our X values, we have to be in between 4.5, that would be here, and 6, which would be here. Notice I'm using solid lines. My lines are solid because there's an equal to component on both of my inequalities. Since X has to be in between these two values, we shade right here in between. For the walking miles, Y has to be in between 9 and 12. So 9 would be here, and 12 is here. And since you have to be in between these two values, this is the region we shade. Now finally, we need to erase any shading that doesn't satisfy both inequalities. So it has to be shaded with both blue and red. Here, this is only blue, and this is only blue. Oh no. So I can erase also some of this red down here. I'm really bad with my eraser. I keep erasing my lines. So the only region that we need to fill in is right here in this little box. So we've answered part A. Part B says, list 3 possible combinations of working out and walking that meet his goals. So we can pick any 3 points in this region. How about this point, and this point? The 3 points I identified look like, if we're going to do X, Y, so that's gym, walking miles, the 3 solutions I identified look like 5, 10, 5.5, 11, or 6, 12. These would all be solutions that satisfy the inequality. Now it's time for our last problem, number 11. Work on this one on your own, and then when you're ready, we will do it together. Welcome back. Emily wants to buy turquoise stones on her trip to New Mexico to give to at least 4 of her friends. The gift shop sells stones for either $4 or $6 per stone. Emily has no more than $30 to spend. So we've got 2 different types of stones. We've got $4 stones. Based on our graph here, we're going to call that X. And we've got $6 stones. We're going to call that Y. So Emily wants to buy at least 4 stones. So since she's going to be buying X number of $4 stones and a Y number of $6 stones, the way we represent the total is X plus Y. And she needs 4 stones at least. Pay attention to that phrasing. So X plus Y has to be greater than or equal to 4. The next piece of information we got from the problem is that the different prices, when we add all that together, it cannot total more than 30, so no more than 30. So we would write that like this: $4 times the number of those stones she buys, plus $6 times the number of stones she buys at that price, can be no more than, so less than or equal to, $30. These are our two equations, but if we want to graph them on this coordinate plane, we're going to need to rewrite these in slope-intercept form. So for my first line, I'm going to subtract x from both sides and throw a 1 in front of that x to make it easy to find your m and your b. If our y-intercept is 4 and our slope is -1, we're going to go down 1, right 1. We will have a solid line going down in this direction. For the blue inequality, we need to subtract 4x from both sides. So that's going to give us 6. Oh, I made a little mistake here. This should be a y. It's going to give us a 6y is less than or equal to -4x plus 30. And when we divide both sides by 6, we end up with y is less than or equal to -2/3 x plus 5. To graph this one, we'll start with a y-intercept of 5, and we'll go down 2 and right 3. And this line is going to be solid as well. Let's look at our shading now. So the red line will be shaded above because we have a greater than or equal to symbol. So that's all of this area. And the blue line, because it's a less than or equal to, will be shaded below. So based on this image, we need to identify what region is shaded with both blue and red. And it looks like just the region between the two boundary lines. So I'm going to erase all this other shading. And our solution is right here in between the two lines. Part B asks us to list 3 possible solutions. So we can pick any points in the shaded region or on the lines. It can be on the lines because these are solid lines and solid line points are included in the solution. So I'm going to pick this point, and this point. Emily can buy, let's look at the first point I drew on the left. She can buy 1 $4 stone and 3 $6 stones. Or she could buy 3 $4 stones and 2 $6 stones. Or she could buy 6 $4 stones and 1 $6 stone. These are all possible solutions. There are many more possible answers, so your answers could have been different from mine for part B. But as long as your points are somewhere in this region, your points are correct. And that's a wrap.